Hi everyone, welcome to Netgate Chemistry. So this is going to be the last video of chemical bonding. In previous videos we have studied about the hybridization, non-bonding electron pair repulsions, and now we are going to study about the rules of VSEPR for comparison of bond angles. Rules of valence shell electron pair repulsion for the comparison of bond angles. So there are three rules. Rule number 1 is that the bond angle is inversely proportional to the number of lone pairs on central atom. So if number of lone pairs are more, then bond angle will be less, and number of lone pairs are less, then bond angle will be more. For example, your NH3 having one lone pair, your water having two lone pairs. Here number of lone pair is 1, here number of lone pairs are 2. So if number of lone pairs are more, then bond angle is going to be less here, and bond angle in NH3 will be more. Similarly, I can compare this with CH4 also. It is not having any lone pair or zero lone pair. You can say it is having zero lone pair, it is having one lone pair, and this is having two lone pairs. So trend of bond angle will be like this. I hope rule 1 is clear, but there are some conditions for rule 1 to be applied. What are those conditions? Conditions for application of rule 1. First condition is that rule 1 is applicable only on the molecules having same hybridization. That is, molecules should have same hybridization. If we look at our example, this one, this is having sp3 hybridization, this is also having sp3, and this is also having sp3 hybridization. Why? Because all of them have steric number of 4. See, there are 4 bond pairs, 3 bond pair and 1 lone pair, steric number 4, 2 bond pair and 2 lone pair, steric number 4. For steric number 4 we have sp3 hybridization. All of 3 are having sp3 hybridization. So first condition was satisfied in the previous example. Second condition is rule 1 is only applicable when NB non-bonding electron pair repulsions does not dominate. NBEPR should not dominate, and we know when the conditions in which NBEPR dominate, that we have studied in the previous video. So these are the two conditions. So that's it for the rule number 1. Now rule number 2. Bond angle is inversely proportional to the electronegativity of side atoms. Okay, that is, if side atoms have more electronegativity, then they will be having lesser bond angle. This one is also having some conditions for their application. Condition 1 is same, that is molecules should have same hybridization. Second condition is that non-bonding electron pair repulsion should not dominate. These two conditions are same as for rule number 1, but there is additional third condition, that is your number of lone pairs should be same and should exist also. So there is a compulsion of having lone pair, and that too having number of equal lone pair in each molecule for condition or rule number 2 to be applied. For example, NH3 NF3. If you look at the side atoms, these are F is more electronegative than H. So if F is more electronegative, so because it is inversely proportional to the bond angle, so it will be having less bond angle. So trend of bond angle will be like this. We can find out whether conditions are satisfied or not. Both are having, this is having steric number 4, this is also having steric number 4, this is sp3 hybridized, this is also sp3 hybridized, so having same hybridization. NbEPR is not dominating here, because first condition for NbEPR was that central atom should be big, but a central atom is small. So first condition is not satisfied for NbEPR to dominate. Third condition was number of lone pairs should be same and should exist. Lone pair are existing and they are 1 in number, so rule number 2 is applied here. That's it for rule number 2. Now rule number 3. That is bond angle is directly proportional to the electronegativity of central atom. Okay, the conditions for this rule to be applied are same as rule 2. Okay, but here we have to see the electronegativity of the central atom. For example, take the nitrogen family: phosphorus, arsenic, antimony and bismuth. Take same side atoms. Side atoms are similar, only central atom are different. All of them are having one lone pair. Number of lone pair are for bond angle, electronegativity of central atom. If it is more, then angle will also be more. So trend of electronegativity is that phosphorus is more electronegative than arsenic, then antimony and then bismuth. So similar trend will be followed for bond angle. So this is your rule number 3. Okay, after this, see, now we have studied about the hybridization, non-bonding electron pair repulsion and valence shell electron pair repulsions. Now we are going to find out whether which trend to apply first and then which trend to apply next. So for that we have to do an absolute comparison for bond angles, because we have studied about the hybridization also, NbEPR also, and these 3 rules of VSEPR also. So now we want to find out which concept to apply first while looking for the bond angle in different molecules. So first of all, you have to see the hybridization of the molecules. Whichever number of molecules are given to you, just find out the hybridization of each molecule. So the trend of bond angle amongst different hybridizations will be sp having 180-degree angle will be having most bond angle, then sp2, then sp3, and then your Dragos compounds having no hybridization. Okay, they are having angle of 90 degrees. Okay, so this will be the trend of bond angle from 180 to 90. It goes from 180 to 90 as per the hybridization. The second, if the molecules are having same hybridization, so amongst the molecules having same hybridization, go for NBEPR. Just see whether non-bonding electron pair repulsions are dominating or not. There will be two cases. In one case, answer will be yes, they are dominating, or maybe they are not dominating. The cases in which NBEPR dominates, in that case bond angle will be more. We know that. We have seen the example of OCl2 in which NBEPR was dominating due to these lone pairs. So what was happening? Due to these repulsion, bond angle was increasing. So the cases where NBEPR is going to dominate, in that case bond angle will be more. If by chance there are some cases in which NBEPR is not dominating, then you have to see for valence shell electron pair repulsions. Go for rule number 1, 2 and 3 to find out the trends. Okay, if by chance valence shell electron pair repulsions are also the same, okay, there is no difference, then they are having same bond angle, then the molecules will be having same bond angles. So if there are some number of molecules given to you and they are asking about the trend of bond angle in those molecules, first look for the hybridization. If it is sp hybridized, then it will be having most bond angle, then followed by sp2, sp3, and then the case of Dragos compounds, that is no hybridization. Then look for NBEPR. If it is dominating, then bond angle will be more. If it is not dominating, then go for VSEPR rule number 1, 2 and 3. If VSEPR is also not being applied, then molecules are having same bond angle. So with this, chemical bonding is over. Then I'll be making some videos on the previous year questions of chemical bonding. Thank you so much for watching.